The quickest way to sharpen your mind is to study explanations of underlying principles. Over the next 2.5 years, I'll guide you through a systematic breakdown of the structural principles behind all manner of things. Today, we're looking at wind turbines and exactly how they generate electricity. Surely it can't be that difficult. Just a few large blades turning slowly to produce power, can it? As it happens, that's exactly how it works. It simply relies on the blades harnessing the power of the wind, and through a series of energy conversions, transforming this intangible wind energy into electricity we can use. And these large blades are no ordinary pieces of metal. A single one can be over 80 meters long, longer than a football pitch, to withstand millions of rotations and extreme weather conditions such as torrential rain, gale force winds, and lightning. Engineers have specifically used glass fiber and carbon fiber, reinforced with epoxy resin composites, to create blades that are lightweight enough to be easily moved by the wind, yet sufficiently robust, wear-resistant, and fatigue-resistant. However, the blades only rotate about 15 times per minute. At such a slow speed, the generator simply cannot produce electricity. The rotational speed must be increased, but the blades are thick and heavy, forcing them to accelerate risks breakage. What is to be done? Clever engineers designed a gearbox, much like fitting the wind turbine with an acceleration gear. Through the meshing of internal gears, they take the blade's low speed of 15 revolutions per minute and boost it 100-fold to a high speed of over 1,500 revolutions per minute. This allows the generator to operate normally, but the wind is never constant. Sometimes it's strong, sometimes it's weak. The blade's speed fluctuates, resulting in an unstable frequency of the generated electricity. Yet the grid requires the frequency to be precise. Even a slight deviation could trigger a power cut and damage equipment. So what should be done? The engineers fitted the generator with a doubly fed system, equivalent to an intelligent frequency stabilizer. When the rotational speed is slow and the frequency is low, it compensates for the excess frequency. This way, regardless of whether the wind is strong or weak, the electricity generated remains stable and meets the required standards. But if the wind turbine is facing away from the wind, the blades simply won't turn. We can't very well rely on people to manually adjust the direction, can we? So, engineers installed a wind tracking device at the rear of the nacelle, an anemometer and a wind vane. They act as the wind turbine's nose and eyes, monitoring wind direction and speed 24 hours a day. If the wind direction shifts by even a few degrees, a signal is sent to the computer in the nacelle. The computer then activates the yaw system, which uses a massive motor to rotate the nacelle, ensuring the blades are always facing the wind to maximize the capture of wind energy. Next, the generator converts the high-speed mechanical energy into electrical energy through the principle of electromagnetic induction. Simply put, the rotor inside the generator rotates within the stator, cutting through the magnetic field lines. This naturally generates an electric current. However, the electricity produced at this stage is low voltage and cannot be transmitted directly to homes. It must pass through a transformer at the base of the tower to step up the low voltage electricity to high voltage levels of 33,000 volts or more. This reduces energy loss during long distance transmission and prevents electricity from being wasted during the process. Once the blades start turning, the rotational speed increases, the frequency stabilizes, and the electrical output rises. Then the lights, air conditioning, and fridges in our homes can then be powered by clean, environmentally friendly wind energy. For wind turbines to operate reliably year-round, regular maintenance is crucial, just as a car requires regular servicing. The key maintenance points for wind turbines lie in the lubrication system and connecting components. The gear meshing points in the gearbox and yaw system must be kept adequately lubricated at all times. If the lubrication system fails, dry grinding of the gears can cause malfunctions and even lead to a fire in the nacelle. The connecting bolts between the blades and the hub, and the fasteners at the tower joints, must also be inspected and tightened regularly to prevent loosening or detachment caused by prolonged rotation and vibration. Every maintenance session requires a thorough inspection to prevent minor faults from escalating into major problems. However, this type of conventional wind turbine is only suitable for areas with stable wind conditions. In extreme environments where there is little wind year-round, or where wind speeds fluctuate wildly, alternative methods of power generation must be employed. So, do you know what other methods are available?